Have you ever looked at the periodic table and wondered what it all means? Well, today we're going to crack a chemical code that's been hiding in plain sight. It's a fascinating puzzle that explains why some elements act like total opposites, even when they're right next door to each other. And that's the central mystery right there. How can two families of elements, living side by side on this famous chart, have chemical personalities that are just polar opposites? It seems like it shouldn't be possible, right?
Let's think about it like this. On one side, you've got the social butterfly, so reactive it wants to bond with literally anything it meets. And right next to it, you have the lone wolf, so stable and content it wants nothing to do with anyone else.
So let's properly meet this chemical odd couple. We're taking a trip to the far right side of the periodic table to get to know group 17 and group 18 a little better.
First up, in that second-to-last column, say hello to the halogens. This family includes some pretty famous names like fluorine and chlorine. And their name says it all, you know? Halogen literally means salt former. These guys were born to react.
And then, just one spot over, in the very last column, we find the noble gases. We're talking helium, neon, argon, the quiet, kind of aloof neighbors. They're typically colorless, odorless, and famously unreactive, the total opposite of the halogens.
Okay, so let's get to the heart of this mystery. What is the big secret? You're not going to believe how simple it is. It all comes down to one single tiny particle.
So the halogens, they have exactly 7 electrons in their outermost shell. 7. Just lock that number in your brain for a second.
And the noble gases? They have 8. That's it. That one little difference, 7 versus 8, is the secret to this entire story. It changes everything.
So what exactly are these super important particles? Well, they're called valence electrons. These are the electrons way out on the edge of the atom, and they are basically the atom's personality. They control everything, how it behaves, who it bonds with, the whole shebang.
And this right here is the golden rule of chemistry. The ultimate goal for pretty much every atom is to get a full outer shell of electrons. Why? Because a full shell means stability. It's the most relaxed, low-energy state they can be in. It's atomic zen.
Now, this isn't just some abstract theory. This constant atomic quest for a full electron shell has massive, real-world consequences. Let's see how this tiny drama actually shapes the world all around us.
Let's take regular table salt. You have sodium, which has 1 extra electron it is dying to get rid of to be stable. Then you have chlorine, our halogen friend with 7, who is desperate to gain just 1 more. It's a perfect match. Sodium just gives its electron to chlorine, and bam, they form this super stable compound we sprinkle on our food.
And of course, we've learned how to put this reactivity to good use. We use chlorine's aggressive nature to keep our swimming pools clean. Fluorine's knack for bonding helps protect our teeth from cavities. And iodine is actually essential for our health. Their desperate need to react is incredibly useful to us.
All right, so let's flip back to the noble gases. Why are they so chill? It's simple, really. Their outer shell is already full. They've already reached that chemical nirvana, so they have zero motivation to go out there and react with anyone. They're perfectly happy just the way they are.
But don't mistake unreactive for useless. No way. In fact, their stability is their superpower. We use helium's safe, non-reactive nature to fill birthday balloons. We zap neon with electricity to light up those iconic city signs. And argon's stability creates a little protective bubble inside light bulbs so the filament doesn't just burn up instantly. Okay, so let's bring it all home. Let's put everything we've learned together for one final, side-by-side look at our chemical odd couple.
It really all boils down to this, doesn't it? Halogens have 7 valence electrons, they're super reactive, and their life's goal is to find 1 more electron. Noble gases, they have a full shell of 8, they're unreactive, and their goal is just keep things exactly as they are. Every single property flows from that one simple difference.
So the biggest takeaway here is that the periodic table isn't just a random collection of elements. It's a map. It's a beautifully organized map of behavior. An element's address, its exact position, tells you a whole story about its personality and lets you predict how it's going to act. And that kind of leaves us with one final incredible thought. If a single tiny electron can create such a world of difference between next-door neighbors, it really makes you wonder what other amazing secrets and hidden patterns are just waiting for us to discover on this incredible map of our universe.